One of the main problems with publishing an event to a message bus every time a change is saved to your database is, what happens if you save the change, but then the application crashes before the event is published? Or worse, what if the event is published, telling the subscribers that something has happened, but then the related change is never actually made? So which do you do first? Saving changes to your database and publishing an event to a message bus are both independent network operations, and no matter which order you do them in, there's always a chance that your process stops before the second one happens, whether that's an exception, or maybe the network goes down, or there's a power cut where your server is hosted. You could try to do them at exactly the same time, but still, one could fail. And it could turn out that either your database was down, so the changes were never saved, but you just published the event, or the other way around, you saved the changes, but there's no event. We need both of them to happen as one atomic operation. That means the whole thing cannot be subdivided into smaller things. The original request is either successful, and both of those things happen, or it fails, and nothing happens. But there's no in-between state. There's no partial success where only some of the things happened. The solution to this is to implement the Transactional Outbox Pattern. So what is that? Well, most databases, including relational databases like SQL or a document database like MongoDB, have a transaction feature. We can begin a new transaction, and then make several changes, then commit the transaction, ensuring all of those changes are saved as one atomic operation. We can utilize this for our events. We start a new transaction, then we make the change, let's say we're updating this user's name, and then we also insert our event into a separate database table, which we'll call the Outbox. Then we commit the transaction containing both of these changes. Now, we didn't actually publish the event to a message broker at this point, but we have saved a record of our unpublished event to our Outbox. This record will always exist if the changes were made, or, if there are any failures, neither the change or this record will exist. Now we just need to publish the event to the message bus, and once we do that, we can remove it from the Outbox. If the process dies before we manage to publish the event, then it remains in the Outbox. Similarly, if there's a failure publishing the event for any reason, then we don't delete the record from the Outbox. We just leave it there, and we can safely continue and behave as if everything was successful. For those events that get left there, we'll need to implement a separate background task that routinely gets the events from the Outbox, publishes them, then deletes them. Okay, but if we keep exploring these cases where a network call fails, what if we publish the event and then we fail to remove the entry from the Outbox because maybe the database went down or the process died just after we read the event from it? In this scenario, the event remains in the Outbox and gets picked up again later when this process comes around a second time. Maybe even a third time or a fourth time if it keeps failing. This is called at least once delivery. Yes, we risk publishing duplicate events, but we accept that is better than risking not publishing them at all. Choosing at least once delivery means subscribers must be aware that they may receive duplicate events. To combat this, the actions we take when receiving the event must be idempotent, which means it will produce the same result no matter how many times the event is handled. Some actions are naturally idempotent, such as setting a value. It doesn't matter how many times I try to change this value to 123, the end result is always the same. The value is set to 123. But other actions, such as increasing the number by 10, are not idempotent, because if we perform that action twice, the number will increase by 20. One way to deal with this is to give each event a unique key and use that to deduplicate the events, ensuring we ignore events with keys that have already been handled. These are the sorts of complex problems that arise from building distributed systems such as microservice architectures where networks are unreliable but we want consistent data. Feel free to explore the other videos on my channel about these topics here. Thanks for watching.